All right, today we'll be moving ahead in section 2.3 today. 2.2 is really just going over how we display categorical data, or also called qualitative data. And it's usually bar graphs and pie charts. And you've seen these for many, many years in many, many different topics and other subjects. So I'm not going to spend a lot of time on that. You guys know how to read bar graphs. How are they different from histograms? Histograms were quantitative down here, right? It was like a number line, and we made classes. If they're categories, we use bar graphs and actually usually separate the bars. Okay, that's all was really going on in 2.2, and I didn't think we need to spend a lot of time on that because you've had so much experience with it. 2.3, stem and leaf displays, not as much experience. We need to make sure we go over this. Okay, so now we're back to quantitative data. All right, so go ahead and pause the video, read these first two pages to get going. Okay, if you didn't find the definition yet, here you go. Go ahead and write this down. Stem and leaf display is a method of exploratory data analysis that is used to rank, order, and arrange data into groups. More specifically, it's quantitative data. I probably should have put that in there, but there you go. All right, this procedures down here will serve as your success criteria for making stem and leaf displays. All right, the left part of the display is called the stem. That's kind of where it gets its name from, okay? The rightmost part is called the leaf. Okay? You always put this in order from smallest to largest. A vertical line separates the stem and leaf. Okay, and then if they have the same stem in common, they go in the same row. It's easy to do. Once I show you once, you'll get it. Here's one of the most important things, though, with the stem and leaf. You need to make sure you create some type of key. So use a label to indicate the magnitude of the numbers. In case it's a decimal, for example, if I had a stem and leaf, and here's my stem and here's my leaf, I don't know if that's 34. I don't know if it's 3.4. It could even represent 340 if I rounded things to the nearest tenth. So this could represent a lot of things. So the key is very important. Okay, let's go ahead and take a look at example 6 and then the explanations after that, pages 72 through 73. Pause and take a few minutes to do that. Okay, so here's the key. You can grab any piece of data you want. They grab 32 pounds. But it doesn't matter. If you're doing this, you can grab 51. Okay? Now, the first one, they just kind of threw it together and they said, well, this isn't quite correct because we like to put it in order. So this is the final product here. All right? See how there's a little gap just so you know that there's a new data value. So this is 12, 12, 17, 18, and so on. Okay? So you just kind of cross them off as you go. Start with the smaller numbers and work your way up. And try to use context for your key as well. Okay. Now, stem and leaves actually kind of look like histograms if we turn this sideways. So what do I mean by that? If I turn this sideways, this would be classes, right? This is a class of 10 pounds to 19 pounds. So that's kind of how we do histograms, right? 10 to 19, 0 to 9. 20 to 29. So if I turn it this way, it's the height of those bars, right? Okay, so if I ask you what's the shape of the stem and leaf, or what's the shape of the distribution, that's what you do. You just kind of turn it sideways, and then you can realize it's maybe roughly mound shaped, but here it looks like it skews maybe just a little left. I'd say maybe slightly skewed to the left for this one, okay? All right, so let's give this a try. In your notes, go ahead and read the looking forward, and then let's start doing guided exercise number 4. Okay, and once you read through it in a moment, I'll make sure you're starting it correctly with the correct stems. But start by reading it, get it going, and then I'll make sure you're starting it right. Okay, so they're telling us to use the first 2 digits as the stems. So like, anything in the 110s, they want to be in the same row. Anything in the 120s, they want in the same row. So like the leaf is going to be this one, and then the stem are these. All right, so if it's below 100, we'd write it like this. So here's kind of our first row. 0, 8. 83 is the lowest number of points, wherever it is. There it is. Okay, so that means its stem has to be 0, 8, and then 3. All right, so from there, you continue and finalize that stem and leaf. All right, here's your feedback. This goes too quick too. This is also on page 74 for you to check. Just make sure you have all these digits. Make sure you have a little gap in between these data values so you can tell, and make sure it's in order. Okay, choose one of these and include a key somewhere. What does this represent? I did 0, 8. Line 3 represents 83 points. Okay. There will be a small short answer part of the quiz tomorrow that has you create some things. It's hard to kind of do all this on multiple choice. But. All right, and then B, the interpretation. Looking at the distribution, would you say that it's fairly symmetric? Turn it sideways. Yeah, it's pretty symmetric, right? Kind of draw a line in between it. Does it look? It's roughly symmetric. Obviously not perfectly symmetric. But yeah, we'd say this is roughly mound-shaped and roughly symmetric, okay? So that's what I put. Appears mound-shaped and fairly symmetric. All right. Okay, and then let's take a look at the bottom of page 74 for a little recap. Give you a minute to read that. We'll talk about it, and then I'm going to show you a back-to-back stem and leaf plot. Okay, so all those things that they just talked about, it does, it kind of makes it nice and tidy, right? It takes this raw data, which is tough to really analyze, and puts it into a nice display. Smallest to biggest. If there's an outlier, we'd be easy to see, because let's just say I had 170 as part of this data set. We'd see some gaps. I'd have 150, nothing there, 160, nothing there, and then finally something at 170. So outliers are very easy to spot if it's part of the distribution. Okay. All right, last thing I want to show you is the back-to-back stem and leaf plot. One of your problems in your assignment deals with this, and let me show you how to read it. Okay, here's a back-to-back stem and leaf plot. Okay, you'll understand the setting once you read number 10, but basically it's some type of archaeology problem where there's site 1 and site 2. So they use the same common stems in the middle, and then they put site 1 over here. So this is 25 centimeters. This is 30 centimeters, 35 at site 1, and so on. So when you read it, you just kind of look, okay, I'm going to ignore the right side, and this is my site 1 data. And then if I want to look at site 2, I ignore that, and there's my stem and leaf for that. Does that make sense? So common stem, a way to compare the two sites. Okay. All right, that's a wrap on 2.3. It's a small section.